Today we are going to talk about this interview question asked by Amazon, Apple, and Adobe. We are given the array nums of distinct integer and we need to return all the possible permutations. Distinct integers means there's no duplicates in the array. We should keep that in mind. There is one good observation that you can make before the implementation. For the array 1, 2, 3, at first, you have 3 options that you can choose from the 3 elements. As we are moving to the second index, we have 2 elements left because we already spent 1 element on the first index. And on the last index, we only have 1 option to choose. So at total, we have 3 times 2 times 1 permutations. Again, you can observe the permutation into a tree structure. On the root level, which is index 0, we can select all the elements from the array. On the second level, which is at index 1, we can only choose the element except the root. So if you choose number 1 at index 0, the only option left we can choose at index 1 is 2 and 3. Again, if you choose number 2 at index 0, you can only choose 1 or 3 at index 1. And here's what you can understand the recursion. I did not RC as the recursion function name. Initially, we put the empty array as the parameter. As we're traversing the array at the first level of recursion, we put number 1 at index 0 into the array. After that, the recursion function will call itself. So that result into the second recursion call will bring in the array as the parameter. On the second recursion, we are going to traverse the whole array again. At first, we know that number 1 is already in the parameter. So we need to skip number 1 and add number 2 in the parameter. The recursive function will call itself again. That result into the third recursion. And we also need to bring in the previous 1 and 2. As we are looping through the array, we know that number 1 is already in the parameter, number 2 as well. So we're adding number 3. Finally, it hits our base case, that the length of the current, which is the parameter, is equal to the length of the numbers. So this is the cur, and it has the length 3. And this is the numbers, it has length 3 as well. And we append the array in the parameter to the answer variable. The answer variable is outside of the recursion. As we're returning, that concludes our first recursion call, which is 1, 2, and 3. Now you may notice that I include the column sign here. In Python, that means we are returning the copy of the array. Because the cur variable, which is the parameter, it can be changed later in the next recursion call. For example, on here, you can change to 2, 1, and 3. So if we directly assign the cur variable, instead of the copy, into the answer array, this subarray can be changed later. And here's the whole Python code. Notice that we need to pop the element from the cur after we return from the recursive, because let's say if we hit the base case here, we need to pop the last element, which is 3, in order to have this if statement to be true in the future recursion. So on the second level of recursion, we also need to pop the last element, which is 2, in order for the next for loop call to add number 3 here. In terms of the time complexity of this question, it is very tricky and you need to be careful. As I just mentioned, the numbers of possible permutation we have is equal to n factorial. Again, at first we have 3 options to select. At the second, we have 2 options because we already select 1. And at the last, we have 1 options. So the total permutation we have is 3 times 2 times 1. And this actually equals to the number of leaf nodes here. However, you will notice that we have the copy array sign here. So in order to copy it, for example, 1, 2, 3, into another addresses, which is 1, 2, 3, this will also take O(n) operation. So at total, the time complexity is n times n factorial. If you like this channel, please click like and subscribe. Thank you.